Today's video is a continuation of what we started with yesterday, so please go back to where you left off. We need to be on page 332 in the textbook. So we're following up our work on parabolas and moving on to ellipses now. So an ellipse, of course, is an oval-shaped figure. The standard form of the equation of ellipse, that shouldn't say from, it should say form, centered at the origin with a major and minor axis of length 2a and 2b, is going to look like the following. So if the major axis is horizontal, in other words, the ellipse is going to lay wider on its side than up and down, you're going to use x squared over a squared plus y squared over b squared is equal to 1. If your major axis is vertical, in other words, your ellipse is going to be tipped up like this, x squared over b squared plus y squared over a squared. Now again, the length of the major axis is going to be 2a. That'll be the distance all the way across, with the center being in the middle of that. So if we're looking at this with our center here, this whole thing is 2a. That's the entire major axis. So half of it is a single a. Okay, the minor axis is going to go the short way, the whole thing again being 2b, which means one section of it is just b. The vertices and the foci are always on the major axis, so we will have foci for these conics as well. There is a relationship between the lengths of a, b, and c. That relationship is c squared is equal to a squared minus b squared. All of that information, by the way, from those first two slides was found on that box on page 332. Okay, so those would be good things for you to make sure that you have marked down on your sheet. Now, if you need to find the standard equation of ellipse, okay, first identify the foci. These are going to give you that number c. Look to see the length of the major axis. Okay, so if you're provided with a picture, you should be able to see this, or maybe the problem is just going to give you the length of the major axis. Half of that is going to be a. Okay, use the values of the two that you know to solve for b. Now it's possible too that they might give you the length of the minor axis instead, in which case you would have b. Again, you're going to be able to determine two of them. Use whichever two you know to calculate the one that you don't, using that c squared equals a squared minus b squared thing. Write the standard equation then using those numbers that were found for a and b. So checkpoint number 3 says find the standard form of the equation of the ellipse that has a major axis of length 10 and foci at 0, -3, and 0, 3. Now, first thing that I generally do with this, if I know that my foci are 0, 3 and 0, -3, those 2 points lie on the y-axis. That has to be my major axis, so I know that I have a vertical major axis. Okay, so my ellipse is going to stand up by an end kind of like this. Now I also know that my major axis has a length of 10. Well, the major axis is 2 a's, so half of that is from the center to the outside, so I have an a length of 5. Using those two then, I can find b. I'm going to get rid of my little picture here again so I can write. So knowing that c squared is equal to a squared minus b squared, we determine that, or we could determine that, I guess I didn't write it down yet, c must equal 3 if my foci are 0, -3 and 0, 3. So c squared is going to be 9. A squared is going to be 25. We don't know b squared yet. Okay, so solving for b squared, I'm going to have b squared is equal to 16. So b is equal to 4. Okay, so if we were going to come up with our equation now, because I had a vertical major axis, I'm going to use the form x squared over b squared plus y squared over a squared. Again, that's right out of that table, right out of that chart that was on page 332. So x squared over 4 squared, or 16, y squared over a squared, which is 25, is equal to 1. Okay. Sketching this ellipse. First of all, with given the equation 4x squared plus y squared equals 64, I don't have a 1 on the right-hand side, so that's going to be something for you guys to watch for when they give you the equation itself. Notice in that box both of the standard forms, whether or not the major axis was horizontal or vertical, the value on the right-hand side was a 1. So I need to divide everything in this equation by 64 to get that 1 over there. Okay, now this first one reduces. So trying to determine whether or not we do have a vertical or horizontal major axis, you need to look at those numbers that are sitting underneath underneath your x's and your y's. Okay, looking back at the chart, A is always going to be your major axis number. A is always going to be bigger than B. Okay, B is always the minor, A is always the major on an ellipse. So since this is the bigger value here, this must be our A squared. Okay, which therefore makes A equal to 8. That then leaves this digit underneath the x squared to be our b squared. So b must be 4. Okay. Now, if a is lined up underneath the y squared, we must have a vertical major axis. Okay, again, that comes right from the box. If a is underneath the y squared, we have a vertical major axis. So our vertex is still, or our center is still at the origin. If a is 8, this is going to be on the outside of my ellipse, as well as this. My minor axis is going to go the other way, so B tells me how far to the right and to the left my ellipse is going to go. And just draw your ellipse. Our other shape, our fourth conic that we're going to talk about, are hyperbolas. Hyperbolas are the set of all points x and y in a plane for which the absolute value of the difference of the distances from two distinct fixed points called foci is constant. That's a lot of wording. Hyperbolas are going to be the ones that are two disconnected curves that kind of mirror each other. Okay? Like I was saying, the graph of a hyperbola has two disconnected branches. The line through the two foci intersect the hyperbola at 2 points, which are your vertices. Instead of calling our axes major and minor this time, we are going to be focused on the transverse axis. It's similar to the major axis. It will connect the vertices. And the midpoint of that transverse axis will mark the center of your hyperbola. Standard equations of the hyperbola. Now these are coming from the box on page 335. Okay, you'll notice that a lot of things are very, very similar to your ellipse. Okay, so it takes a little bit of work, but the nice thing is the hyperbola and ellipse are very identifiable simply by looking at the operation in between the pieces of your equation. Notice that in between our parts on the left-hand side, we now have subtraction. Okay, with our ellipse, if you remember, there were addition signs in between there. So that's going to be your first giveaway. Also notice that your A's and B's don't swap positions this time. It's the X's and the Y's do. Okay, so those are the major differences between our ellipse equations and our hyperbola equations. The rest is a lot alike. Okay, which I suppose, can make them easier to switch around and mix up. So that's where you have to work at it and become comfortable with the use of these. Okay, so these two come right from the boxes, as well as this. The vertices are A units from the center. Okay, that's very same with our other conic shapes. The foci are C units from the center. Again, those two are going to line up on the same axis. Again, there is a relationship between A, B, and C. This time, though, the relationship is B squared equal to C squared minus A squared. Okay, so make sure that you have this all down as well. Again, page 335 is the box from that I got this on. Now I went online and I found a couple of diagrams that kind of give you a visual for what this looks like. The hyperbola is that kind of purplish blue curve of this picture. The red lines mark asymptotes, so we've worked with asymptotes already. To come up with those lines that form those asymptotes, you're going to use those same A's and B's that we are finding through our calculations and through our playing with our points. Focuses, okay, notice where the focus points are. They are still inside the curves, just like they were with our parabolas and ellipses. They were still inside the curve. I think that's about all I wanted to point out on this picture. And again, you can see the standard form of the equation up there in the corner for this vertical transverse axis. Here's the horizontal one. Okay, so again, the relationships are there, the positioning of the things are there. It's just sometimes the visual is helpful. Asymptotes, again, are the red lines. Still utilizing the A's and B's, but notice they are, flipped from what they were before, and so on and so on. So depending on whether or not you have a horizontal transverse or a vertical transverse, of course your things are going to change. This is, again, the information from table 335, just put in picture form. To find the standard equation of a hyperbola, if you have the foci, again, you have C. If you have the vertices, you have A. You can put A and C into that relationship that we got from our chart or from our table. B squared equals C squared minus A squared, and you can get that B that you need. Put A and B into the standard form, and you have it. So let's give this one a try. Find the standard form of the equation of the hyperbola with foci at 0, 6 and 0, negative 6, and vertices at 0, 3 and 0, negative 3. All right, so again, kind of give yourself a visual. 0, 6 puts a foci here and here. 0, 3 and 0, negative 3 are vertices, so our curves must do this. Remember, the foci are going to be inside those disconnected curves. Now, there's a relationship between those. If we know that our vertices or our foci are 0, 6 and 0, negative 6, we should be able to determine our C value is 6. Our vertices are 0, 3 and 0, negative 3. Those give us our A's. Now, use that relationship that we copied off of our table. On our hyperbolas, we have B squared equals C squared minus A squared. So we do not have B. C was 6. So 36 is C squared, and A was 3. So B squared is 27. B then is going to be the square root of 27, which is 3 root 3. Okay, so you have what you need to come up with that standard form of the equation anyway. We actually also have pretty much what we need in order to be able to do our sketch. Now, one other thing that we're going to find to help us with the sketch, if we were to do one, well, I guess we don't need to do that on this one yet. That'll be coming up on checkpoint number 7. So sorry, I'm going to ignore me on that one. We don't have a graph or grid on this slide, so we're not going to make the picture. Let's go back and find our standard form. All right, so this must be your transverse axis, which is clearly a vertical one Okay, the transverse axis is the y-axis, which is vertical, which means we're going to use this format or this standard form to fill in. Okay, now we can use our a's and b's that we found. So x squared over 3 squared is equal to subtract y squared over 3 root 3 squared is equal to 1. Cleaning that up, x squared over 9 minus y squared over 27 equals 1. I would take either of those. I think the second one looks a little bit better. Now, in helping to sketch with the hyperbolas, here's where we're going to bring in that asymptote thing. Each hyperbola is going to have two asymptotes. They're going to be slant ones, and they will intersect in the center of your hyperbola. The axis that runs from your negative b to b is called the conjugate axis. Okay, so the major one, remember, was called your transverse axis. The other one is the conjugate axis. The asymptotes form the diagonals of a rectangle. Okay, I'll show you how we can kind of sketch that rectangle to help us. But we can also use our a's and b's to come up with those equations of lines that can be sketched as well. All right, so here's how we find those asymptotes of the hyperbola. After you have found b's and a's, okay, if you have a transverse axis that is horizontal, y equals b over ax and y equals negative b over ax are your asymptotes. You can graph those lines. Okay, you've got slope-intercept lines there. B over a and negative b over a are the slopes that you'll have on those lines. If your transverse axis is vertical, it's kind of the flips of those. Okay, so if the transverse axis is vertical, you have y equals a over bx and y is equal to negative a over bx. Sketching this one then. Okay, so checkpoint number 7. I'm just going to rewrite this a little bit so that I'm actually seeing a denominator under my x squared as well. I'm going to rewrite that 4 as a 2 squared. Okay, now in a hyperbola, remember, this first term is always your a. That never swaps. The second one is always the b. So now if I'm coming up with my asymptotes, a is 1, b is 2. For this one, let's see. We had x squared first, y squared second. So off of our table, we have a transverse axis that is horizontal. Okay, so our vertices are going to be horizontal or side to side from each other. A is 1. So at negative 1 and positive 1, we're going to have our vertices. B is 2. Now remember, that's on your conjugate axis. So that's going the other way. So remember how that one slide said that those points could form a rectangle whose diagonals were your asymptotes? Let me just kind of dot in the rectangle that contains those 4 points. See these diagonals coming through here? Those are those asymptote lines that we would be finding. Okay, now I'm going to show you how to find them with our information from our boxes or from our tables. Okay, so for the hyperbola with a horizontal transverse axis, remember that we had y is equal to b over ax, and we also had y is equal to negative b over ax. Okay, so filling in a's and b's, we'd have y is equal to 2 over 1x and negative 2 over 1x. Now if we came back over here, slope of 2 on my first one, do you see how those diagonals are going to give me that same line that I'm graphing now using our equations over here? That negative 2x, here's the line with the negative 2x slope, same thing. Okay, so there's two different ways to come up with those asymptote lines in order to help you get a better picture for your hyperbola. Now the focuses, they're going to be located inside the curve, but this particular problem did not ask you for them. Let's go ahead and calculate it anyway though. So we need our relationship between our A's, B's, and C's. Okay, so on a hyperbola, again, B squared is equal to C squared minus A squared. So B squared is equal, whoops, we got B, I'm gonna fill that in. B squared is going to be 4. C squared we don't have. A squared is 1. Add 1 to both sides. So the square root of 5 is C. Now the square root of 5 is a little bit more than 2. So here are your focus points. And again, they're going to be inside the curve. They don't help you a whole lot with the shape or the size of your hyperbola, but those asymptotes do. Okay, because your curve is going to stick and hug them pretty closely. And there we go. There's a hyperbola, the blue line. All right, checkpoint number 8. Find the standard form of the equation of the hyperbola that has vertices at -1, 0, and 1, 0, and asymptotes of y equals -4x and y equals 4x. All right, so vertices of, and again I'm giving myself a visual, -1, 0 and +1, 0 mean I have, okay, this has got to be my transverse axis, so it's a horizontal again. Okay, so knowing that I have a horizontal transverse axis, I should be able to then go back to my table and write down the standard form of the hyperbola that I'm going to be writing. So on a horizontal transverse, we have x squared over a squared minus y squared over b squared is equal to 1. All right, so if I know my vertices, I have A. A has a length of 1. Now the only other information this story problem gave us were our asymptotes. Y is equal to -4x and y is equal to 4x. But remember, each of those, if we have a horizontal transverse, remember how our asymptotes were b over ax and negative b over ax? Okay, that -4 and +4 are your b over a. So b over a is equal to 4 over 1. So now I know my b and I know my a. Okay, so using that, I can come up with my equation that I need to write. So x squared over a squared, we said a was 1. I keep writing an equal sign in there. Minus y squared over b was 4. And if you wanted to clean that up, we would see x squared over 1 minus y squared over 16 equals 1. All right, now that marks the end of what I have for you. I would like for you to give these 6 problems a try, okay, and have them turned in to me on Monday. If you have any questions to them or with them, make sure that you're in early enough to ask. Hopefully you won't have any difficulty with them. Do many, many, many more. Get good and comfortable with section 4.3 before we go on to 4.4.